Welcome to Engineering Principles. Today what we're going to be talking about is engineering and engineering technology. So the idea is what is engineering? So engineering is the application of science and math to solve problems. Engineers figure out how things work and find practical uses for scientific discoveries. Scientists and inventors often are credited for inventions that advance human conditions, but it's the engineer who are instrumental in making those innovations available to the world. Now, engineers versus an engineering technology. This is kind of a spectrum thing. An engineer will sit on the more left-hand side of this platform, while the engineering technologist will sit on the right-hand side of this. Engineers will be the more people who do the more bookwork, mathematical, more computational research, complex analysis, design, development. While the technologists are going to be the ones actually working on the floor, making or selling or building the actual products. So they're going to be in distribution and selling, technical analysis, production, routine design, tests and evaluations. Now, of course, there is some overlap here where manufacturing and test evaluation, both engineers and technologists will work together. Just realize that they're not necessarily independent of each other. They rely on each other, but they do have different jobs. Now, how to get a career in engineering? Well, first way is you first have to graduate high school. Then you can choose different options. There is getting an associate's in engineering technology and then going straight into your college job. There's also getting an associate's in pre-engineering. Several universities, Weber State being the most prominent one, and then getting a bachelor's degree in either engineering technology or engineering itself. You could also commonly, and this is the most common one that most of the students will do, is going straight from high school, get their bachelor's degree, and then go into the workforce. There is also usually at the latter half, you can go get your upper level degrees, such as master's degrees or doctoral degrees. Any one of these options is possible. So notice there's multiple pathways. None of these are wrong. Now we're going to talk about ABET. ABET is an accreditation board for engineering and technology programs. Universities and colleges have to be ABET certified in order to give you an engineering degree. So anybody can open up a university or a college and say, I'm going to give you a degree. But if it does not fit within the ABET, it is not a certified engineering job. So you have to look at the universities that you're going to look into and see if they are ABET certified. If not, do not go to those universities. They won't give you any applied science, natural science, computing, engineering, or engineering technology like credits. It won't count for anything. Now, there are different types of engineers. Here is a list of the recognized, ABET recognized ones, but there are other ABET, other programs that don't fit under the ABET accreditations, such as architectural engineer, ceramics engineer, construction engineer, management engineers, mechanics, physics, metallurgy, optics, surveying, welding. Engineers. These are all engineers, but they aren't officially ABET certified. Still can work as a welding engineer. They're just not an ABET one. So let's go through these. We're going to go through a handful of these and talk about them. But there's aerospace, health and safety, agricultural, industrial, biomedical, marine and ocean, chemical, material, civil, mechanical, computer hardware, mining and geological, electrical, nuclear, electronics, petroleum, and environmental. So aerospace are going to be designing and building things that fly, either in air, that's the aero part, or in space, the space part. So these can be planes, spacecrafts, helicopters, missiles, weapon systems, all sorts of things. Agricultural engineers are going to be the ones that are engineering crops. They are going to be looking at designing and constructing and improving farming equipment and machinery. Here's a quadcopter that you can actually fly over crops, dusting it using drone technology. Then you have biomedical engineering. These are going to be using devices for the idea of medicine and biology for usually healthcare purposes. You're going to be building artificial organs, medical imaging devices such as MRIs, prosthetics, bacteria production of medicine. So you genetically alter bacteria to produce medication. Insulin is a common one of those. There's chemical engineers. These are going to be engineering chemicals. Now, this is not a chemist. As a chemist will produce a new chemical, chemical engineers are going to make it in the batches. They're going to manufacture more of that same chemical. They're going to work in, big giant factories kind of like this, where they're going to create and take raw material and make some new chemical that is needed in the world. Civil engineers build things that don't move. So if it doesn't move and it's not supposed to move, that is a civil engineer. Dams, roads, sewer systems, pipelines, structural components, buildings, railroads. These are things that they would build. Computer hardware engineers are going to be people who build the actual computer components of the actual computer. So they're building the actual bits and parts of a computer, designing networks or building computer systems for NASA or analyzing system requirements. Now, electrical engineers are much more on the bigger side. They're going to be looking at systems like electrical equipment or large-scale electrical systems, such as electrohydrical dams or power systems. They can go as small as like a test aircraft electrical equipment or oversee electrical utilities. So these are they can be as broad as an entire state and be as down to as small as a car or even a computer. Electronics engineering is going to be more dealing with the small parts. They're going to be looking at small electrical systems such as cell phones or surgical devices, making the newest tablets, video game consoles. You could invent medical microrobotics for human bodies. Environmental engineers solves environmental problems such as pollution or material or energy use and how we create waste and how to clean that up or prevent it from having to be cleaned up. Health and safety engineers identify potential hazards and develop protocols to prevent those hazardous situations. They might prevent workplace accidents or enforce measures in nuclear accidents or reduce traffic accidents. Industrial engineers are going to be ones that are going to be working in industry. They are going to be the overall planning structures and layouts and production facilities. They're going to be looking at how things are made on a large scale. Improve efficiency in hospitals, determine machine layouts in a manufacturing facility, design stadium facilities for convenient uses. Marine and ocean engineering is going to be building off like oil rigs, and they're going to look at maintaining structures that exist near the water. So like oil rigs or deep sea explorations. You could be working on submarines, things of that nature. Boats. Material engineers are going to be ones that are going to be making new materials to specific design purposes. You're going to be trying to develop new things like new combat uniforms for the military, or maybe new materials that can replace burned victim skin, so artificial skin. Maybe protective material used by space astronauts here. This white fabric on the astronaut here is actually a protective, very unique material. Helps prevent overheating of the astronauts while they're on their spacewalks. There's a lot of different materials. Now, mechanical engineers, which is the most popular type of engineering and probably the one you're probably thinking about going into, but is not the only one. This is ones that deal with moving things. So civil engineers deal with non-moving things, mechanical engineers deal with the moving things. They design cars, determine how to use new lasers, maintain power production equipment such as wind turbines, build, produce machines. This is going to be your kind of most broad spectrum engineering field, but is not the only one. Then there's mining engineering and geological engineering. These are going to be people building how do you locate and find new deposits in the ground for extracting ores and creating stuff from the earth. How do you detonate and explode explosives so you can get to those rock ores, creating safe and accessible mine shafts and that kind of thing. You can think of like Kennecott copper mine. Nuclear engineers are people who build and maintain nuclear power plants, whether that can be on a submarine or an actual industrial power plants. They also are not just in maintaining, they can also use for like nuclear medicine and radiation therapy, developing methods to utilize nuclear energy on spacecraft. We have several probes that use nuclear technology that power them. There is petroleum engineers, and petroleum engineers are going to be locating oil and natural gas reserves and how to extract them and transport them so that we, the consumers, can use them. They're going to try to determine the most cost-effective way of locating them and extracting, and how to find them and locate them. Now, your first assignment is going to be what we call the career portfolios. This is going to be located in your Canvas under section 10, and this is 10.1. What you're going to have to do is you're going to be choosing an engineer or an engineering technology career you would be interested. And then you're going to submit via Canvas the answering to these questions. What is the job you're interested in? What do those and those jobs do, build, or but be specific? Are there specific geographical locations for your job? What is the work environment like? Is the career very specialized or is it general? What degrees, certification, and tests would it take you to have this job? This is going to be very specific. There are tests that you have to take to be an official engineering. You have to get what certifications. Now, this is the part that everybody's going to hate me for, and I am sorry, but we're going to go with it. All sources, all of these questions have to be cited. So you have to cite all of them, and then you have to cite them using either MLA or APA formatting. Here is the portfolio that I need you, or the rubric for that career portfolio. So I'm going to give you guys 12 points for this assignment. This is worth 10% of your total grade in this class. Actually, it's worth 5%. Because you'll have 10.2 is worth another 10%. So, or another worth 5%. So you have the content. You answered all the questions thoughtfully and completely. It is grammatically correct with no spelling errors, and there is a lot of trustworthy sources. So please make sure you use your sources. Every single question should have at least one, if not more, sources that you cite where you got your answers. So if you have any questions, please ask me, and have a great day.